Okay, hey guys, we're at Unit 4, Lesson 4 now, and we are zooming in on multiplication. So we've already started with area, and now we're going to go back specifically to multiplication, and we're talking about powers of 10. So in today's mini lesson, the problem of the day, I think, has some misalignment issues, but really it's just trying to get the kids connected to fast facts. This takes us back to the place value misconceptions kids had, and we want to make sure that we know we don't always just bring down a zero. We really think about that's 1 power of 10, 2 powers of 10, 3 powers of 10, and that's how we've moved place values. So I am going to ground today's lesson in a place value chart, even though the exemplar model from the network and the lesson plan itself doesn't. I think it's going to help our kids. So I think just FYI for you, remember, when I do this work, it's so you know how to do the work. It's not 100% model of what you're going to teach, like how you're going to teach it to the kids, right? This is me teaching you how to do the work. All right, so here we go. Tennis balls come in a package of 3. Stephen has 4 packages of tennis balls. Manny has 40 packages of, tennis balls. And David has 400 packages. How many tennis balls should each of these boys have? Use place value blocks, drawings, equations, or place value charts to help prove your choice. And so the fact that this flat out says place value blocks is like giving me that in to sort of ground everything in place value, even though, again, today is about the rule of adding a 0 to a fast fact. All right, so tennis balls come in packages of 3, jot 3 per pack. That's my multiplier. Great. Stephen has 4 packages of tennis balls. S equals 4. Manny has, Stephen, 4 packages. Manny has 40 packages. Manny has 40. M equals 40 of tennis balls. And David has 400 packages. Whoa! David has 400 packages. D equals 400. How many tennis balls does each of these boys have? That's my big question. Let me box that and label that. Remember, we do not pass go. All of our kids have to make sure their work, anytime they read a story problem, looks like this. Use place value blocks, drawings, equations, or place value charts to help you use your answer. So these are just like tasks, things that I need. So the first thing that I want to do is, let me just get some jots down on the paper here. I know that my multiplier equals 3. I know that Stephen has 4 packs. I know that Manny has 40 packs, and I know that David has 400 packs. Great. What else? Knowns and unknowns, sort of, and my jots can go together. But what's unknown in this problem? How many tennis balls does each, that's important, boy have? So, what are my tasks today? Task 1, solve for Stephen. Task 2, solve for Manny. Task 3, solve for David. Whew, lots of tasks. Let me go back to my big problem. Yep, that's it. I'm not putting them together. I'm not combining them. So I have to make sure that I'm clear on my big problem and I'm clear on my tasks. All right, so let's solve for Stephen. I know S. Let's see if I've got an equation here to help me. So S equals, I've got my packs, 4. I've got my multiplier times 3. So that's a fast fact, but let me just go ahead and the rest of my equations. Task 2, solve for M. M equals, remember, come back over to my jot, 40, and I've got my multiplier times 3. D, right here, come back to my jot, D equals 400 times 3. All right, so I've done all the hard work of figuring out what I'm solving for and setting myself up for success. Here's where the powers of 10 is going to come into this lesson today. So kids are going to use place value blocks, drawings, all kinds of things to help them out. This is where you know you're going to have your in to get them into the power of 10. So let's check it out. 4 times 3 equals, well, task 1. I just know that 4 times 3 is 12. I'm good with that. It's a fast fact I just know. Task 2. Ooh, 40 times 3. Well, I could go 40 plus 40 plus 40. 40 plus 40 is 80, plus another 40 gives me 120. So I feel good about that. All right, whoa, task 3. Let's see, 400 times 3. All right, well, same thing. I could do 400 plus 400 plus 400. That gives me 800. Bring down that 400. That gives me 1200. All right, so I'm feeling pretty good like I've solved. But man, these numbers are getting bigger and bigger and bigger, and it just so happens that everything has zeros on the end, making it easy. So this is what we want kids to like tackle and try to do on their own. Ideally, they'll use repeated addition or fast facts to help them out. Then our job is to say, all right, we put up a kid's paper under the dot cam and we show some stuff and we say, we're going to go back to powers of 10 and this idea of like, there's a simple rule we can use every single time that we're working with math and we're working with digits that end in zeros to help us with powers of 10. So let's practice. We're going to, the rule, so you would put this up and you would show the kids that you know 3 and you know 4. 3 times 4 is, yes, 12. 3 times 4 is 12. But when we're working with powers of 10, instead of doing repeated addition, I mean, I would have to do 30 40 times, right? I did 400 3 times, so I have to go 30 plus 30 plus 30. I have to do that 40 times, and we're not going to do that. So instead of using repeated addition, we're going to work with the power of 10, work with the power of 10. And you say, I had 12 of my just know fast facts, but I have these 2 zeros. They're not worth nothing, right? They're actually placeholders. Each zero gives me a power of 10. Here's my first power of 10. Here's my second power of 10. 30 times 40 is 1200. I know that because even though 4 times 3 is 12, I have 2 powers of 10 or 2 zeros, right? 2 placeholders that I have to add back to my fast facts. Then you actually, the work is written kind of weird. Then you actually go down to the rule that's here before you have the kiddos go back up to practice. So team, the rule is when multiplying by multiples of 10, and I would just have this written on your paper already so the kids can just write it. The number of zeros at the end of the product after the basic fact, right, is equal to the number of zeros in the factors. So let's go back up to the top. Here's my basic fact, 3 times 4. And how many zeros do I have in both my factors? 1 0, 2 zeros. So how many zeros do I have to have in my product? 1 0, 2 zeros. That's what that's saying, that guys. Because the powers of 10 in the product have to match the powers of 10 in the factors. So you go through the rule. Then basically what you're asking the kids to do over and over again is this. 7 times 4 is 28. That's a fast fact. 7 times 4 is 28, but I have 1 power of 10, so now my answer is 280. Even though the lesson plan doesn't say to say that power of 10 every time, I want you to, right? I've multiplied by 1 power of 10. Great, 7 times 4 is 28. 1 power of 10, 2 powers of 10. So my answer is 2,800 or 2,800. 7 times 4 is 28. 1 power of 10, 2 powers of 10. So I'm still at 2,800. And kids might get tripped up over, oh, wait a minute. So I can do 7 groups of 400 and get 2,800? Yes. I can do 70 groups of 40 and get 2,800? Yes, because the basic fact, that doesn't change. What you're changing is the degree of powers of 10. Does that make sense? That's what you would say. Okay. So then you come over here, they would try one more, and just so you're crystal clear, let's do this. 9 times 3 is, yes, 27. 9 times 3 is, yes, 27, but what do I add? 1 power of 10. 9 times 3 is, yes, 27, what do I add? 2 powers of 10. 9 times 3 is 27, what do I add? 2 powers of 10. And that is what they're doing in today's lesson. Again, it's tricky because we want to think about like this place value chart that we did. And the ones, tens, hundreds, the thousands, the 10,000s, and the 100,000s. and we talked about how we moved it over 1 power of 10, 1 power of 10, 1 power of 10. Today's lesson is more about that fast fact rule, and so bringing it back to this place value chart could cause confusion for kiddos, but you do want to keep using that language power of 10, power of 10, power of 10. Okay, so they go on to workshop, and they do more of that. You're circulating, and you're actually listening for power of 10, right? 6 times 1 is 6, add 1 power of 10, and that's sort of what you're looking for and listening for kids to be doing today. All right.